So what we are doing today, which we'll get into shortly, we're going to go now more specific. Yesterday was more general. An introduction to notation, introduction to factorials and what those are, introduction to summation notation, sigma notation, what that is. So it was kind of an introductory section of things you're going to see. Today, we're going to start getting more specific on things we're going to look at. But before we do that, questions from the worksheet? Anything you want to go over before we move in? 12?
Sometimes on the first page, so like the first 5 terms, you include 0.
Yeah, I'm not sure why. I'll talk about that. Hold that thought. Okay, couple things. First off, on page number 1, when they ask you to write out the first 5 terms, really you're kind of plugging stuff in and just plug in 1 for n, plug in 2 for n, and just kind of evaluate and see what the actual sequence is. Quick heads up, I have no idea why the answer key is this way. In general, I'm going to give you a general rule to going forward. Unless they tell you to find the 0 term, okay, don't worry about it. Start with the first term. The reason I say that is for some reason on the answer key, some of them included the 0 term and some of them did not. Okay? And so what I'm going to tell you is unless it specifically tells you to find the 0 term, just start with term number 1, term number 2, term number 3. Okay? So just as a heads up on that one. When you take a look at problem number 12, problem number 12 is a factorial problem, so quick reminder. A factorial is an operation, okay? It's a new operation that you were introduced to yesterday. And it is when you're multiplying, if I ask you what 10 factorial is, you start off with that number and then you multiply by 1 less, all the way down to 1. So 10 factorial would be 10 times 9 times 8 times 7 times 6, all the way down, okay? Now, it's a little more difficult on problems like 11 and 12 in your assignment because you don't have numbers, so you can't just evaluate. So you have to understand the concept of it. And we got to think of this as factors. When you look at these two parts, top versus bottom, which factor is the bigger one? The bottom one. Why, Sadie? Yeah. You got 2n plus 1 versus 2n minus 1. The reason I say that is we're going to work our way down to the other one. That's the one I'm going to work on. So I'm not even going to touch the top factorial. I'm going to leave it alone. 2n minus 1 factorial. Let's just leave that as is. In the bottom one, we're going to start to write out the factors. The first factor will be 2n plus 1. What's the next factor then? Yeah, 1 less. Just like when I said 10 factorial, it was 10, then 9, then 8. So 1 less than 2n plus 1, you no longer have the plus 1. Now you're at 2n is the next factor. What would the next factor be? 2n minus 1. You subtract 1 again. You're just going down by 1. And if you notice, now we're at the same spot as the top. So rather than keep going and then say 2n minus 2, 2n minus 3, 2n minus 4, everything from that point forward will now have the exact same factors from top and bottom. So, cancel the top, cancel everything after that on the bottom, and we end up with, reminder, there's still a 1 on top. So it's 1 over those 2 factors. Okay? Yeah?
Do the factorials cancel also?
Yes, because when you cancel, remember what the factorial is. It's just a bunch of factors. So you're canceling all the factors. Therefore, you're canceling the factorial. Okay? Yeah.
So do we always start with the one that's bigger?
Yeah. So in general, I don't know if you heard that question. Question was, so in general, do we start with the one that's bigger always? Yeah. Because as you start to factor, eventually you'll get down to the smaller one, and then everything will cancel out from there. Okay? So you always want to start with the bigger of the 2 factors, and eventually cancel out going forward. Okay, so that's kind of, there's 12. Other questions? Anything else you want to go over?
Let's do 18.
Okay, 18 sounds good, that's fine. Okay. So you take a look at this. Again, just a quick heads up, quick refresher again from from yesterday. What is this symbol? Yeah, sum. This is capital sigma, okay? Which sigma notation, also called summation notation. Anytime you see that, you take the sum. And here's what I was talking about before, where I said unless they tell you to evaluate and take the zero term, don't worry about it, start with the first term. Here they are telling you to start with the zero term. And then what does the 4 mean? Through the fourth term. So we need to find the value of the zero term, first term, second term, third term, fourth term, and then add those up. That's what we're going to take a look at. So if you take a look, if I plug in 0 into the formula, -1 to the 0 power is what? 1. Yep. Anything to the 0 power is 1. Denominator, 0 plus 1 gives you 1. So there's your first 1 over 1. If you want to reduce it to 1, that's fine. Okay? There's the 0. There's your initial value, if you will. Next term, we plug in 1. We end up with -1 in the numerator, and I end up with 2 in the denominator. -1/2 is what you end up with when you plug in 1. Yeah. So we've got the 0 term, we've got the value of the first term. Now we move to the second term. We plug in 2. -1 squared. Back to +1 again. Plug in 2 into the denominator, and now we get 3. And at this point, I mentioned this yesterday, once you have at least 3 terms, if you now start to see the pattern, you don't need to keep plugging in and evaluating. You can just use the pattern to finish this off. Notice, positive, negative, positive. Next one's going to be negative. And then it's over 4. If you plugged in 3, that's what you would end up with for I. And now we need to plug in 4, or just get the last term. And you end up with a +1 over 5. So here's your 0 term, first, second, third, and fourth. And now you add them up. Okay? And yesterday I showed you on the graphing calculator, so that you don't have to do this by hand, how to type them all in and then change it to a fraction. Okay, use the graphing calculator. Do I need to go over that again as a refresher, or are we okay on that? We're good? Yeah. Now I would plug them into the calculator and add them all up. Okay? Remember, once you type those in, anytime you type in fractions into the calculator, put them in parentheses. And then, remember, it's the math button, and the very first thing listed is change to a fraction. So type them all in. It's going to give you some decimal answer, and then change it to a fraction on the calculator. That way it's a more exact answer. I don't really want the decimal answer. I would like the fractional answer. Okay? Because then you don't have to round. Other questions? Anything else you want to go over from the assignment?
Can we do 1 in 5 through 8?
Sure. Anybody have a specific one, 5 through 8, that you want to do? Any of the recursive ones?
Pick a hard one.
If you have one,
Let's just do.
go ahead. Yeah, one you want to do?
No,
No?
I didn't do any of them.
Okay. Yeah, that's perfectly fine. Let's go. Anybody? Let's take a look at. They're all about the same, to be honest. So if you understand one, hopefully you can understand all. Which one? 8? 8 it is. How about 8? All right, let's take a look. Okay. So same thing. We're still now, it's a different, we don't have a formula per se. We don't have the explicit formula. This is the recursive version, which the difference is the explicit formula, you plug in numbers. And then you get first term, second term, The recursive describes the pattern of the sequence. Are we adding 2 every time? Are we multiplying by 5 every time? What are we doing? And so notice we already have our first term. It is 14. Okay? And the recursive part, you have to be able to read that. You have to be able to understand what is that actually telling you to do. So here's the first question I have for you. If this is the k plus first term, where is the k term in relation to that? It's the one before it. K plus 1 is the one after. So here's what this says, and then I'll plug in some numbers so you can see it. This says to find the next term, k plus 1, the next one. You take the term before it and multiply by -2. That's all this says mathematically. To get the next term, you take the term before it times -2. So here's the term. In order to get the next one, all we have to do is multiply that by -2. We get -28. And then do it again and again and again. Okay? Now, if that doesn't make sense, let me give you an example here. Let's say I just pick a number for k. Okay, so you can actually see what's going on. If the k plus 1 and the k is not making sense, pick a value. Let's say I wanted to find let's say I plug in 5 for k. If I plug in 5 for k, that means this would become a sub 6 equals -2 times a sub 5. That might make a little bit more sense. To find the 6th term, you take -2 times the 5th term. If I plugged in 4 for k, to find the 5th term, I take -2 times the 4th term. Okay, so if it's not quite making sense with the k plus 1 and the k, I would suggest putting some numbers in and then seeing kind of what's going on. How do I find the 6th term, the 7th term, in relation to any term before it?
Is A
Okay.
the term number?
So like a sub 6 would be the value of the 6th term. So to get the value of the 6th term, we take -2 times the value of the 5th term. Okay? So the pattern is really multiply every time by -2. That's really what that's saying. Does that make more sense? Yeah, question?
Should we do number 14?
Sure. If you take a look before we do that, by the way, for example, on like number 5. What does it tell you to do on number 5? What's the pattern? Add 3 every time. On number 6, what's the pattern? Times 1/2 every time. Number 7, what's the pattern? Subtract 5 every time. That's all that's saying. That when you do recursively, it's just describing the pattern. Okay? All right, which one did you tell me, Alex?
14.
14? All right, let's take a look. Oh, yeah, 14 is a little bit confusing. Just the first 5 again. First 5 terms. For the whole front page, first 5 terms.
I don't know what I'm doing.
All right, so on 14, this one's mathematically, again, not difficult, but understanding the symbols and what's actually going on here is confusing. This one's a little bit tricky. So notice we are taking the sum of the first through the 4th term. Okay? First, second, third, fourth. Here's the tricky part. Here's how this one's different from the rest. There's no I in there. So what's the first term? 10. What's the second term? 10. What's the third term? 10. So what this is saying is every term in the sequence is 10. That's what that is saying. Because there's no I to plug in. So the answer is 40. Yeah. Okay? So the answer is 40. That's the tricky part, is every other one has an I and it actually has a formula you can plug in. This one is just 10, 10, 10, 10. 10 is the sequence. Okay? Any other questions before we move forward? Or are we doing okay now? We've at least got through some of the summation stuff, some of the factorial stuff, and then some of the formula stuff. So we've kind of hit all 3 types. All right. I'm going to have you put that aside then, and let's go into what we're going to do today. All right, so here's the idea. As we're now starting to move forward, that section yesterday, the stuff we just went over, was kind of an introductory section of summation, factorials, things that you're going to see in the chapter, okay? But was kind of all over the place. There was not really a ton of connections. It was just, here's a bunch of things you're going to see, okay? Now we're going to start to get into more specifics. We're going to look at two types of sequences and series in particular in this chapter. The first one that we're going to take today and tomorrow, we're going to talk about what is an arithmetic sequence in series. And we'll talk about what makes it special compared to every other sequence. And then next week we'll get into a geometric sequence in series. Okay? First, heads up. When we talk about sequences and series, sequences are just number patterns, just written out. First 5 terms, first 10 terms, whatever. A series is when you take the sum. Okay? That's called a series. Okay? So a series is just the sum of the first however many terms. That's the only difference between those two things. We'll talk about both of them today in terms of arithmetic. All right, so here's your definition. Here's what makes a sequence, specifically an arithmetic sequence. It's when you have consecutive terms that have a common difference that we're going to label as the variable d. Okay, common difference. So when I say a common difference, what we're looking at is, it's a common thing that's being added every time. The same amount. Plus 2, plus 2, plus 2, plus 2, plus 2. That makes it, if that happens, it's an arithmetic sequence. Okay? Plus 5, plus 5, plus 5. When you add the same constant, that common difference every time. So for example, this would be an example of an arithmetic sequence of numbers, because what's the common difference here? What's the pattern? More specific. Numbers. What's the common difference? 5 halves is 2.5. This is 1.5. So you're going 3, 2.5, 2, 1.5, 1. So what's happening? Yeah. The common difference is negative 1/2. Every time, in order to get the next term, it's negative 1/2, negative 1/2, negative 1/2, every time. That is what makes this specifically an arithmetic sequence. Okay? One of the reasons why we look specifically at arithmetic sequences, and you'll see it as we move forward here, but an arithmetic sequence, because it's constant, because it's a constant sum, it's a constant addition problem, it turns it in to, this is really just a linear pattern, where the common difference is like your slope. Okay? If you think of a line, you've got a constant slope of a line, regardless of which 2 points you pick. Well, if I plotted the points, for example, if this was my first term, second term, third term, fourth term, fifth term, if these were my x-coordinates, 1, 2, 3, 4, 5, and those were my corresponding y-coordinates, you'd be plotting a line with a slope of negative 1/2. That's why an arithmetic sequence is unique. That's why we look more into it, because it's really just a linear pattern. Okay? Let's keep going. So what about this one? If we take a look, kind of like what we were relating to what we did yesterday. Here's an explicit formula, and I want to write out the first 5 terms and kind of state the common difference so we can actually see, is this arithmetic or not? Okay? If it has a common difference, it is. So just like yesterday, in order to find the first 5 terms, just plug in 1 for n, plug in 2 for n, plug in 3. And then we can kind of look at the pattern. We don't necessarily have to plug in all 5. You can now start to see the pattern. But if I plug in 1, start with the parentheses, don't forget order of operations. We get 0 times 4 is still 0. We end up with the first term in that sequence is 1. Okay? Happened to be that number. And I plug in 2, which means I get a 1 here, times 4 is 4, plus 1, give me 5. There's the second term in my sequence. if this is arithmetic, by the way, what's the common difference? Okay, 4. Now, we can't stop here because two numbers is not a pattern yet. Okay, we got to keep going just to make sure. If we plug in 3, you get 2 in parentheses, times 4 is 8, plus 1 more gives you 9. Is this one going to be arithmetic? Yeah. Plus 4, plus 4. You end up with 13, you end up with 17. And again, you could confirm the 13 and 17, plug in 3, plug in 4, plug in 5. You'll get those numbers. So in this case, this is an arithmetic sequence with a common difference of 4. Okay. So another example. Let's take a look at one other one, and then I'm going to move forward. So same idea. Let's plug in. Let's figure out what these numbers are, and we'll see if it's arithmetic or not. See what the common difference is. So if I plug in 1, what do I get for an answer? I get 1. I get 0 as an exponent, and 2 to the 0 power is 1. Okay? If I plug in 2, what do I get for an answer? 2. I get 1 as an exponent. 2 to the first power is 2. Okay? Again, if this is arithmetic, what's the common difference? Yeah, it looks like we're going up by 1. But again, two numbers is not a pattern yet. Okay? So we take a look. Let's plug in 3. What do I get? 4. Let me stop right there for a second. Is this arithmetic? No. There is a pattern, though. I'm going to go a couple more. If I plug in, what do we have? 4. I'm going to end up with 8. If I plug in 5, I end up with 16. Okay? And so on and so on and so on. What is the pattern, even if it's not arithmetic? Times 2. This is what is called a geometric sequence. That's what we're going to take a look at next week. Okay? By the way, I said arithmetic sequences, all they really are just linear functions. They've got a slope of whatever the common difference is. What kind of function is this? This is an exponential function. Remember back to exponential functions, we talked about a common multiplier? There it is. Times 2, times 2, times 2, times 2 when we did exponential growth versus decay. All a geometric sequence is an exponential function. It's got a common multiplier. Okay? All right, so take a look. I don't necessarily want you to write this down. I want you to just follow with me for a second. So again, the issue becomes, as we work with arithmetic sequences, if I wanted to know what's the 50th term, what's the 100th term, I don't want to have to go through and use the pattern to get there. I want to be able to come with a formula. The nice part about arithmetic sequences is there is a formula that works all the time. You don't necessarily have to find, there's a general formula we can come up with. So if a sub 1 is your first term, and we've got a common difference, makes sense, hopefully, that in order to get to the second term, I take the first term plus the common difference, and that gets me the second term. Make sense? Common difference is 2, I add 2, I get the next one. Okay? Now, if we keep doing that, I'm going to keep relating it back to the first term, the starting point of the sequence. If I wanted to get the third term in a sequence of numbers, does it make sense that I would take the first term and add the common difference twice? Does that make sense? First time you add it, you get the second term, then you add it again, you get the third term. It's the same thing, that's why. And if I went to the fourth term, what would I have? Plus 3 common differences. Let me ask you this. If I went to the 10th term, what would I have? Nope. 9 common differences. You take your first term, add 9 common differences, you'd get to the 10th term. If I asked you for the 100th term, what would I have? You'd add 99 common differences to the first term. In general, here's what you're coming up with. You can write that down, yes. Okay? Yeah, I'll have you write that down. I'm going to kind of elaborate on that in a second. That's why I said can. So in general, in order to get any term, you take the first term and add n minus 1 common differences. That's why I asked you about 110. Okay? 100, we added 99 common differences. That's why it's n minus 1. If I wanted to get to the 15th term, I would add 14 common differences. That's why it's n minus 1. Okay? That's where that n minus 1 is coming from. This is kind of the formula that works all the time. There's really two key parts that you need. You need to know your starting point. You need to know your first term. And then you need to know your common difference of what's happening from there. And then from there, what's the 50th term? We plug in 50. What's the 100th term? We plug in 100. Okay? With that being said, here is the general information then for that. So a sub 1 is the first term. Okay? We talked about that yesterday. That's the value of your first term. That's your starting point for the sequence. D is the common difference. That's the pattern. What are you adding every time? And when you're doing an arithmetic sequence, just a quick heads up, you have to always look at it as what am I adding. So even on that one where we were subtracting 0.5, the common difference was not 0.5, it was negative. Okay? You were adding a negative 1/2. That's what you need to look at it as. Okay? And then n is the term number. Okay? We talked about that again yesterday as well. Which term are we talking about? The 50th, the 100th, which one? And you can use that formula to find the value then of any arithmetic sequence. Okay? It doesn't have to be A, by the way. There's some books that use U, there's some books that use other letters. Okay? This one uses A, that's why it's A. So, let me give you an example here. Oh, I forgot about this part. Then I'll give you an example. Or, here's another option. I'm not going to spend a lot of time on this, I just want to make a quick connection on what that actually means. I'll let you write it down and then I'll explain. Because that probably makes no sense to you. Which is perfectly fine. We'll explain. So all this is, I said arithmetic is just a linear function. This is in the same, different variables, but the exact same version of y equals mx plus b. Where your common difference is the slope. That's what I was talking about before. If you're adding 4 every time, well, if you were to graph a line, that's the slope of the line. It would be 4. This constant is really just some y-intercept, like an initial value. That's kind of your a sub 0, if you will. That's your starting point. And then n in this problem, or in this formula, is really just like x. Okay, it acts the same way. Your term number is really just x in all of these things. Okay? So I wanted you just to see that it's the same idea as a linear function. All right, let me give you an example. We'll do a couple of examples of arithmetic sequences here. First one, I'm giving you the recursive formula, some information. I want to rewrite this as an explicit formula. Okay? I want to come up with a formula that I can actually use to find the 50th term or the 100th term. Because right now I can't do that. So what this says, we've got the first term of 72. What does the recursive formula tell you to do to get the rest of the terms? Subtract 6. To get the k plus first term, the next one, we take the previous one minus 6. They're telling you the pattern here is subtract 6 every time. So that means this is your common difference. Common difference is negative 6. And we just said, in order to come up with that formula, let me rewrite it so you have it. Okay. Said I need two things. I need a starting point, which I have, and I need a pattern. I need a common difference, which I have. I'm going to leave n alone because I want to come up with a formula that works for any value of n. That's why I'm not going to plug in a number for n. I don't want, right now, I'm not looking for the 50th term or the 100th term. I'm looking for a formula that I could find any term. So let's plug in the first term of 72. Let's plug in our common difference of negative 6. And now we can just simplify that down to a formula, like what you had yesterday. So I'm going to take that negative 6 and distribute. Okay. So we get 72 minus 6n plus 6, which, when we then clean this up, that means the formula, the explicit formula that goes with this sequence, if we were to write it out, is going to end up being negative 6n plus 78. Yeah, basically. 78 is like your zero term, right? Okay. Which means, and actually I'm going to elaborate off of that, which here's why that'll hopefully make sense. So we said the negative 6 is like the slope. This is like y equals mx plus b. The 78 is like the zero term. Think about that for a second. If you started at 72 and we said we're subtracting 6 every time, what if I wanted to go back one term? Wouldn't I add 6? There it is. There's the 78. The 78 is like your zero term. It's like your initial value. So again, some of the connections that we're trying to make here. Let me stop for a second. Anybody have any questions? Anything not making sense as we're working our way through? Okay, let me give you one more example. This one's a little bit more difficult, but still same concepts. So now, given two random terms of a sequence, we want to still come up with the formula. Okay? I still want to come up with my arithmetic formula. So that if I wanted to find any given term, I could do that. So first question, what two pieces of information do I need in order to come up with the formula? I need the common difference and the first term, which right now I don't have either of those. Okay? But what I'm going to tell you is if I can find the common difference, then I can find the first term. Okay? That's exactly where we're headed. So if this is the sixth term, think about it this way. I'll kind of put this down here. So we've got negative 38. How many common differences would I have to add to get to negative 73? In order to get from the 6th to the 11th term, you're going to have to add 5 common differences. And if you do, you will end up at negative 73. That's why I was going through and I told you not to write that stuff down, but follow along. I'm not going to ask you to prove that, but that's why I did it, so that you're understanding, in this case, to get from 6 to 11, that's just add the common difference 5 times. Now I can solve for the common difference, which is what, by the way? If you do the... It is, I think it's negative 7. Okay, negative 7? Yep, okay. So now I do have a common difference. It is negative 7. We said I still need to find the first term. How do I do that? Close. If I want to work back to the first term, what do? We're going to add it. How many times? In order to get back to the first term, I got to add 5 common differences, but in the other direction, which means how much am I actually adding? 35. And therefore, your first term is negative 3. Okay. So in order to get from the 6th to the 11th, we add 5 common differences to get there. We got to do the same thing, just going the other way, but now we're adding 7 instead of subtracting because I'm working backwards. Yeah, Steve?
Can I find it like a different way?
What way? Yeah, I mean, there's more than one way, but yeah, what are you thinking?
Change of, I think of it being like change of, like slope change.
Like
Is it
slope?
the way you find a slope, yeah.
Yeah, in terms of the common difference? Yeah, you could. So I don't know if you heard that, and it's a perfect connection. Another way to do this, if you're trying to find the common difference. So Tita just said, can I think of this just as slope? We said common difference is slope, right? You can. Change in y over change in x. The change in your y values right there, change in your x values is 5. You would also get negative 7. It's the same exact idea. Okay? It's the same idea. And now that we've got our first term and our common difference, we can plug those in and go right back to, again, finding the formula. Just like we did back here. Plug in the first term, common difference, simplify it down. Okay? How we doing, okay? Making sense, hopefully? I'm not going to finish it just to save a little bit of time. All right, so then here's the other part. And this one I'm going to go straight to the formula and give you this. So when we talk about a series, really the only difference is now we don't have just a sequence of numbers, it's not just a pattern. Now we're trying to find the sum of the first however many terms. Okay, so we're adding them up. But again, if we're talking about 100 terms, I don't want to have to try to find all 100 terms and then add them all up by hand. We want to come up with a formula. Well, I'm going to cut to the chase on this one. There it is. Okay. We could derive this. I could go through and kind of derive the formula again like I did the other one. I'm going to save a little bit of time and just cut straight to it. So when you look at this formula, the S sub n stands for sum of the first n terms. Sum of the first 10, sum of the first 20, sum of the first 100. That's what S sub n stands for. N is still the term number. Okay, that doesn't change. A sub 1 is still the first term. But now, A sub n in this formula, and you may want to make a note of this, A sub n is the value of the last term. So if you're finding the sum of the first 50 terms, A sub n in that case would be A sub 50. Okay? So in this scenario, I need to know three things in order to use this formula. I need to know the first term of the sequence. I need to know the last term in the sequence. And I need to know how many terms am I adding up. Okay? I need to know n. Am I adding 50? Am I adding 100? How many terms am I actually adding? Okay? So, same thing. Let me give you an example. I got two examples for you. Let's start right at the beginning. Let's go right with the formula. Okay. So I am finding the sum of the first 25 terms. By the way, quick heads up as you're writing this down. If I asked you to find the sum of the first 5 terms rather than 25, would I use that formula? I would hope not. You already have 4, you just find the 5th one and add. Okay? So what I'm getting at is think about it when you're doing your assignment. Would it be faster to just add like find 4 or 5 terms and add them up? Or would it be faster to go through and use a formula? If we're talking about 100 terms, then the formula is a much more efficient way. But if we're only talking about 4 or 5 terms or something like that, then just find them like what you were doing yesterday. Okay, so just a heads up. All right, so in this case, if we start using this formula, n is what? Yeah, we're finding the sum of 25 terms. So we're going to go 25 over 2. First term is 2 plus a sub 25, right? I need the value of the 25th term. How do I find that? I don't have that. I mean, you could use the pattern, but we're going to go back to, we're going to use our sequence formula. Let's actually find the 25th term, and then we'll plug it in. Okay? So if we do that, if I'm finding, I'll do it over here. A sub 25, I need to figure out what is the actual value. Well, first term is 2, plus, how many common differences would I add if I'm looking for the 25th term? 24 times, what's the common difference? Yeah, pattern is you're adding 6 every time. What's the value of the 25th term? Now you just do the math. What do you get? Yeah, that sounds right. 146? You get 144, I believe, here, and then add the 2 to get 146. So like I said, it's not super in-depth or anything. We just got to quickly find what is that last value, which in this case is 146. And now you've got everything you need in order to find the sum. Now you can go to the calculator. You got 148 in parentheses times, in this case, 12 and a half. And what's the sum of the first 25? What do you get? I'm guessing you're going to get a decimal. No, I think it comes out 1850? 1,850. That sounds right. So notice, it's a whole lot quicker than writing out all 25 terms and then trying to add them all up. Okay? We can find it using this formula. Okay? One last problem, one last example. Yep. N, same thing. Yeah, N-I-K. Like I said, this book, for whatever reason, uses a bunch of different variables to mean all the same thing. Sometimes it's K, sometimes it's N, sometimes it's I. I don't know why they keep switching, but they do. Okay. So, first question I have for you. How many terms am I finding the sum of? What is it? Why 101? Because we're including the 0 term. We're including that 0 value. So we're actually finding the sum of the 101 terms. Okay? So we're finding S sub 101 equal to 101 then, divided by 2. How do I find A sub 1? Or in this case, A sub 0, really. Because we got to find the first term of the sequence. Yeah, plug in 0. What do you get? 1/2. Yep, you get 8 over 16. So the first term in this sequence, the 0 term, is 1/2 plus, and I'm going to just write this as a fraction because it's not super nice. Plug in 100 to get the 100th term. We end up with negative 292 over 16. I'm going to just leave it like that for now. And again, now we can go to the calculator to work our way through it. Add those two together, multiply by 1 over 101 divided by 2, and, anybody get it? This one I think is a decimal. Or if you change it into a fraction on the calculator. What is it? Yeah? Anybody confirm for me? Anybody? Anybody else with a calculator sitting out on your desk? Can you type stuff in for me, please? Yeah. Yes, no? Okay. You got a different number? What'd you get? Negative 71 over 8? Yes, no? What'd you get?
Negative 896.
Negative 896?
Let's go everything to that. I got.
Oof. All right, let's take a look. My remote's not working, so. All right, let's take a look here real quickly.
Negative 20271.
It was because Addie's was in a decimal, but ours was in a fraction.
What'd you get? The same thing? We're gonna find out. Hang on.
Yeah, okay, no, yeah.
Plus
Yeah.
negative 292 over 16. So if I add those two together, there's what you get inside the parentheses, times 101 divided by 2 equals, that's what you should end up with. There's the decimal version. Negative 896.375. If we then go to math, change it to a fraction, there's your answer. Negative 7171 over 8. Huh? No, you're multiplying. It's that times. You're multiplying right here. You're using the sum formula. In this case, you're using the sum formula. Not the, you're thinking of the A1 plus. You're using the sequence formula. All right, I have 2 things for you today. I do have a homework sheet for you. But the first thing that I have for you is a formula sheet. Quick heads up about the formula sheet. You are going to be able to use this. I would highly recommend you use this as you work through the chapter. You're not going to have it on the test, but you will have the formulas on the test. They'll already be on there for you. So you won't need that formula. Okay? They will be on the test. So you don't have to memorize these is what I'm getting at. Okay? Let me hand out the formula sheet. Let me hand out your assignment.